Hi everyone, my name is Chip Paul and I'm with a company called GnuPharma. And what I hope to do today is present you with our model of human function, which is a little different perhaps than you might have been taught in school. So I want to walk you through this model. I think it's very important. It's a little bit different way to view human function. It's a way for me to explain some very technical and difficult concepts that we've unearthed here at GnuPharma, and to try to explain them to you in a more logical fashion. So we'll see if that works, but here we go. All right, so let me get everything prepared here in a Zoom-like fashion in our new world as we do use Zoom. Okay, whoops, there we go. All right. So I fling my hands around a lot. I'm up here like in the corner. So I fling my hands around a lot, and sometimes I do things for emphasis. So I know it's a little distracting, but I'm going to go ahead and leave this window up here in case I point to something or make some gesticulation that might be important to this overall presentation. And hopefully it'll be a little bit more entertaining as well. So anyway, here we go. GnuPharma, a new model of human function presented by me. I'm Chip Paul. So here we go. What's GnuPharma, or who is GnuPharma? Well, we're a little bit different type of research and development company. So we have based all of our research really on natural products and natural products' abilities to affect all kinds of different systems in our body, but in particular, something called the endocannabinoid system. So you'll see that we started putting out some somewhat claimy press statements. Looks like now, I don't think we put out anything like this now, but back in 2016, we were very proud of our discoveries in the endocannabinoid system, and we really didn't know kind of the law, and we do now, around making claims and things like that. But anyway, these are press releases that we put out. So you'll see in February of 2016, we started talking about some things that we were doing. Now, we're a lot more free to talk about what we're doing now because basically our patents have issued. So we had our master patent issued last year. And so we know we've got a little bit of protection commercially as we begin to talk about things. Again, nothing that I talk about today will disclose any kind of methods involved in our patents, but I will talk about some of the ideas around our patents and why those are important. If you want to know about me as a marijuana activist, you can look that up. But again, the marijuana journey, if you will, the cannabis journey is kind of what led me down this science path. So it's pretty important. You see my lovely wife, Cynthia, there. She has been as much of a part of this as I have. But we've managed to do some pretty cool stuff here in Oklahoma. So anyway, that's subsequent. So we're going to start this. We're going to call this video blog 1, and we're going to date it yesterday, but that's fine because we created the actual blog yesterday. But this is our model of human function. Okay, so it's a little different. And again, we'll get into all that, but I'm excited to present this to you guys. I'm really excited. So perhaps what we were taught in high school anatomy is a bit dated and not quite correct. We work in a logical and elegant fashion that has been obscured in teachings to be overly complicated and frankly, just wrong. And what I mean by that is, if you learn about how a cell works in high school, that's not necessarily wrong information, but that isn't the way that I teach you about anatomy or physiology or how you work. Here, look at the internal valve pressure in this vehicle. This is how a vehicle works. That's confusing, right? Okay, so we're going to come back to this graph many, many times, but I just want to sort of lay the groundwork. So in our minds here at GnuPharma, we work through 4 major systems, all right? One of those systems is spiritual. I'll leave that to you guys, but there certainly is research and evidence there. And we'll talk about the 3 physical systems, okay? So as we talk about these 3 physical systems, we're going to talk about a fat-based system. We're going to talk about how that feeds something that we all have called an endocannabinoid system. And then we're going to talk about this third system that kind of balances and picks up the slack between the other two. And it's a bacterial system that works in our guts and digestion. Isn't that cool? By the way, here at GnuPharma, we have intellectual property around all this. And again, our intellectual property isn't necessarily to be greedy. Our intellectual property is more to keep people out of our way. All right, so let's talk about this first system, and it's really we go evolutionary, it's the first system that developed. So it's a fat-based system, something called triglycerides, which we've all heard a lot about. So let's talk this through a little bit. Where did we develop triglycerides? Well, you got to go way back, but I'm going to use a guy called Sonola Instantelis C-squirt, because he had triglycerides, and he's also the first guy to develop an endocannabinoid system, believe it or not. So you have to go all the way back to when we went. He's also the guy where we went from a invertebrate to a vertebrate, if you go evolutionarily. If you're really into the spiritual system and you're a creationist, if you can't see God in this, because this is beautiful. It really is how we, elegantly work if you kind of look at us from top down. So anyway, how do we store and manage resources for future use? Well, we do it on something called a triglyceride, which is a sugar backbone, glycerol backbone, bound to 3 fatty acids. All right. Well, the fatty acids are what we use for future fuel and future chemical mediators. You can't eat all the time, so you got to store future fuel and future chemical mediators, right? So just like a car, we got to store gas. I mean, we can't be at the pump all the time filling up. We have to store things for future use, and we do that on our triglyceride. So if you look at a triglyceride, again, sugar backbone, you can stick on 3 different kinds of fats on a triglyceride, okay? So saturated fat, which it turns out is really important. Monounsaturated fat, which it turns out is really important. And polyunsaturated fatty acids, which we know, or science knows, are very important because they're called essential fatty acids. These are omega-3 and omega-6 fatty acids, and they're called essential because we can't make them. So your body can kind of regenerate saturated fat and pop it on a triglyceride, or regenerate monounsaturated fat and pop it on a triglyceride, but your body can't make polys, right? We've got to eat polys. So again, on your most important storage vehicle, what are you trying to stick on there? How many omega-3 and omega-6s do you eat? And again, they should be in balance. We should eat those in balance, about a 1-to-1 balance. So good luck even finding them in our diet. And again, the best source of omega-3s is not fish oil. It is something called alpha linoleic acid, and that's found more in plants and in fruit leaves, which we don't even know about yet. So there you go, enterprising young youth, go start harvesting fruit leaves and make omega-3 salads. Okay, so sorry, let's talk about a concept real quick called metabolism. So we've all certainly heard the word, we all have studied probably metabolism, but a lot of us probably have overcomplicated this concept. So let's scale this concept down where we can all understand it. So what is metabolism? Well, basically metabolism is you have these long chain fatty acids, and again, of which the master precursors go on a triglyceride, okay? But you pull these into a cell, and in that cell, you express enzymes based on your DNA, and those enzymes are little scissors. And so a cell will have a function where it's basically pulling in a fatty acid, cutting it up, and making other stuff, right? And so this is the way that basically we make energy. And again, energy is exchanged in this. So we could be acetylcholine going through the Krebs cycle with all of this, or we could be actually enzyming this guy up and sending him out to do other things. So we make other smaller, shorter chain fatty acids. We make enzymes, we make other cofactors, And this all takes energy, right? It takes energy to do all of this. Okay, so again, let's just talk this through with cholesterol, because I think this is important. So in cholesterol metabolism, you have cholesterol as an input, and then as that's input into cells, based on the enzymes in that cell will express something else, right? So what comes from cholesterol? Well, vitamin D comes from cholesterol. How much of us, many of us are vitamin D deficient? I mean, we hear this all the time. We're vitamin D deficient. We're vitamin D deficient. Well, again, it's not because we're not in the sun. I can fix that in a New York minute. Walk outside, right? It's because we don't have enough of the precursor, cholesterol. Isn't that interesting? So we'll talk about that more in a little bit when we talk about saturated fat. All right, another breakdown of cholesterol is something called estrogen. Another breakdown of cholesterol is something called testosterone. Anybody on low T shots out there? Again, why would you have low T? Because you can't make it. Why couldn't you make it? Because you don't have its precursor called cholesterol. Isn't that interesting? 20% of the body's cholesterol is in the brain. How about that, statin drugs? Cholesterol does not cross the blood-brain barrier, so the brain makes its own. Isn't that interesting? The brain makes its own cholesterol. All right, so let's talk a little bit more about kind of how these breakdowns happen. So again, everything you can stick on a triglyceride, you've got sugar and you got 3 fatty acids. How does that get ripped apart? It gets ripped apart through something called the citric acid or Krebs cycle. What is output of that? Energy is output of that. And depending on if the inputs are more sugar or fat-based, ATP, GTP, again, glutamate and GABA are outputs of that. Endocannabinoids are downstream outputs of that. And your basic, very basic inflammatories and immune things are outputs of that. By immune things, I mean like neutrophils and things that will kill, foreign objects, right? Are outputs of this system. Okay, so let's talk about physical system number 2, I guess system number 3, but physical system number 2, which is something called the endocannabinoid system. Okay, wow, we go right back to triglycerides. Why? I thought we were going to talk about cannabis. Everybody triggers on the endocannabinoid system and thinks it has to do with cannabis. Did a C-squirt smoke cannabis? No, he was the first guy to develop an endocannabinoid system. Again, it doesn't grow under the ocean. All right, so let's look at the use of triglycerides again. So again, we use the sugar for fuel. We use the fatty acids for chemical mediators, okay? So what do those look like? Well, it turns out everything you can stick on a triglyceride within 2 enzyme steps breaks down into an endocannabinoid that we use to regulate our body. And that's what the endocannabinoid system does. It's our master regulatory system. We developed it when we had something to regulate. We developed it when we had a tail, which I think I have. Oh, yeah, I'm coming up on that. Okay, anyway, we'll talk about that in a second. But anyway, point of this is saturated fat. What are saturated fats? It really isn't. I used to say this all the time. It's McDonald's. Well, it's really not McDonald's. It's not. It's butter. It's dairy. It's fatted meat that has a lot of saturated fat in it. So that's where we get our saturated fats. I would wager that a lot of us don't eat a lot of that anymore. And if you're not eating saturated fat, you're not making PEA as represented on this slide, which is an endocannabinoid and helps with inflammation, but you're also not making cholesterol, which from a couple of slides ago, we're seeing is testosterone, estrogen, and vitamin D, which we all appear to be deficient in if we, listen to the news. So there you go. All right, so monounsaturated fatty acids, what are those? Well, that's something called oleomide, or breaks down into something called oleomide, which is kind of a PEA and OEA are lesser known endocannabinoids. But polyunsaturated fatty acids, and in particular omega-6 fatty acids, break down into our two major endocannabinoids that, if you studied anything about the endocannabinoid system, you know a little bit about anandamide and 2-AG. So where do they come from? They come from arachidonic acid. Where does arachidonic acid come from? Omega-6 fatty acids. Right off a triglyceride, boys and girls. Oh, isn't that cool? Okay, so let's talk a little bit more in detail about the endocannabinoid system. Again, this is fed by within 2 enzyme steps off of everything you can stick on a triglyceride. So number 1, it's pretty important, and number 2, it's common, and just pay attention, okay? So 3 points about the endocannabinoid system. So first, it's old, which tells us it should be important, because, you know, we developed it before we developed a mouth or lungs or gills or a liver or a stomach or, you know, fingers or toes or eyes or anything. We developed it when we went from an invertebrate to a vertebrate. So it's as old as our spine. There you go. All right. It's as old as our spine. Think about that. So should that tell us all, oh my gosh, it's so important, why aren't we studying it? But anyway, it's as old as our spine. Now, the other cool thing about it is at a sea squirt, that's where we divested from insects. So insects kind of went one way and everything else went the other way. And so everything else has an endocannabinoid system. I mean, for the most part, everything but insects has an endocannabinoid system. How cool is that, man? Your reptile has an endocannabinoid system. Your fish has one. Your dog has one. Your bird has one. Cool, right? All right, so point 1, really old, really ancient. Point 2 is it's looking to be our master regulatory system. So again, real quick point about research. FDA research works like this: FDA, physician, pharmacy, right? So everything that's in that little circle has gone through FDA clinical trials and been shown to be somewhat safe in humans, but none of it is safe, frankly. So they've had to kind of demonstrate that through these FDA clinical trials. So obviously cannabis and things that affect your endocannabinoid system in a broad way, like cannabis, have never been able to get in that. So there's no FDA studies. So what you'll hear physicians say a lot, or MDs a lot, is, well, there's no research on cannabis. That's true, but again, there's tons of research on the endocannabinoid system, and that's the system that cannabis affects, okay? So that is important. Just like, you know, there's not a lot of probably research on morphine and how it affects the endorphin system. It was used to discover it, right? But there's tons more research on the endorphin system because a lot of other things impact it. It's been very well studied. So again, similarly, the endocannabinoid system since the 90s has been pretty well studied. And so there's lots of research out there on it. So you can feel free to look at this slide, use the keywords, nih.gov:"endocannabinoid," 190,000 results. I'm sure it's more than that now. I created this slide probably 2 or 3 years ago. So go for it, right? But anyway, point of this is there is tons of research. And as you read this research, if you're so inclined, what you're going to see is the research is siloed, right? So immune guys write about immune, feeding and craving guys write about feeding and craving, psychologists and psychiatrists write about, you know, mental stuff. But as you read those studies and you look at endocannabinoids, it's very clear, very, very clear that they all agree that the endocannabinoid system is regulating their particular silo. So let's kind of bring this down, got down to a normal level here, and talk about what this means in practicality. So what it means practically is we work kind of like our car. So we understand that in our vehicle, we have a computer, and that computer is always looking at all these major systems in our vehicle, always trying to balance our vehicle to perfect balance or perfect homeostasis, right? And really the only thing that limits it is resources. So if I don't have enough gas, well, I'm not going to be able to get the car down the road. If I don't have enough oil, I'm not going to be able to lubricate the engine. If I don't have spark plugs, I can't create combustion. So it's only resource limited. But anyway, the computer there is using electricity and basically electrical systems and sensors, and then also, mechanisms of change to be able to always balance and always manage that vehicle through these different systems to perfect homeostasis. So guess what? We kind of work in the same way. We don't kind of, we do. We have a hypothalamus hippocampus. The hypothalamus hippocampus uses the endocannabinoid system as its primary sensor array. So again, it's always watching and looking at these different systems. And then it's able to basically use, the hypothalamus hippocampus is able to use the endocannabinoid system to affect change, to kind of up and down regulate, if you will, and make changes through all these systems. And it might be directly like cue a stem cell, you're a bone cell or mast cell or whatever, or well, nerve cell, blood cell, or it might be to indirectly do something like cue the pituitary to release a hormone called ghrelin, and ghrelin is what makes you hungry. And again, why would that happen? Your hypothalamus hippocampus is sensing nutrient need, and so will indirectly basically cue your stomach through the pituitary axis through its release of ghrelin. So isn't that cool? But anyway, it's always balancing, always trying to balance to perfect homeostasis. Whoop, I hit my mic. And what is the rate limiter there? Natural resources. And where do these natural resources come from? So just like in a car, it's rate limited by gas and oil and air in the tires and windshield wiper fluid in the windshield wipers. Well, we're really, frankly, only rate limited by 3 things in the endocannabinoid system, okay? And that's the things that come off a triglyceride, no joke. So again, if we're not putting the right things on a triglyceride, we're not providing the right fuel to our endocannabinoid system, and we will become dysregulated as a result of that. And that resultant dysregulation will be a disease if it's persistent enough. Think on that one. Okay, so let's talk about this last system real quick. It's a bacterial system. All right, well, why do we have it and when do we develop it? Well, what I just told you is everything you need to regulate your body comes off of a triglyceride, okay? Everything that you need to run your body, everything that you need to run your vehicle comes off a triglyceride. Well, where does this stuff come from that you need to run your mind, your cognition, your thinking, your emotionality? Not off of triglyceride necessarily. They come from a different system. So what is this system and when did we develop it? Well, it's a bacterial system. And we developed it about the time we needed to run away. So whatever that little bug was under the ocean or, whatever, when he was like, oh no, I'm going to get eaten, very scared, run away, run away. And that's something called the stress response. We know that in humans is like a fight or flight response. But that response is sort of our basic evolutionary start to being able to build brain chemicals that we need to run our functionality. So what are these chemicals? Again, kind of coolly, it's 3 major precursors again. So again, everything on a triglyceride, and then in your gut, you have really 3 major precursors that are made in your gut, and they're phenylalanine, tyrosine, and tryptophan. And you can kind of tell on this slide, basically what happens here and how they break down. But everything you need, dopamine, serotonin, epinephrine, norepinephrine, all those serotonin, so all those major chemicals come from bacterial processes in our guts. Okay, so isn't that cool? So let's talk about some things again. So interestingly, yeah, okay, I just want to make sure where we're at here. So again, so let's talk about some things that can happen to the gut. All right, so if anybody out there is allergic to poison ivy, again, you think about rubbing poison ivy on your skin. What happens? Well, you'll have an inflammatory response, right? So your skin will get red and puffy. And what I want you to consider is, will you be able to absorb through that red and puffy skin? And I would argue, no. not as well as you could through normal skin, right? And maybe let's give it a factor of a 10th, but who knows? It might be worse. It might be a little better. It doesn't really matter. For the sake of argument, just go with me on a 10th as a factor. So again, you're inflamed. You can't absorb as well. What happens if you eat that poison ivy? Yeah, horrible thought, right? So, but same thing would happen all through your esophagus, all through your stomach, all through your digestive. And basically you would inflame all through your digestive. Well, guess what, guys? We eat poison ivy every single day. If you look at the most allergic foods, they're in everything. And again, you can go to the FDA's website and validate this for yourself. And again, they're in everything, everything. Wheat, soy, corn's not on here, but it should be, although most of us are allergic to corn. But again, we're allergic to these things, okay? We're allergic to these things. That's important. So we're eating poison ivy, a thing we're allergic to, or some of us are, every day. And so what happens? Well, your gut inflames. What does this do to the bacteria in there? Lord only knows, but you know, it ain't good. So you have gut inflammation. And as you're eating, gut inflammation works like this. So your capillaries come apart, right? And as your capillaries come apart, fluid leaks out, and that's what causes the inflammation. But guess what, guys? Fluid leaks in, and in your gut, that is not a good thing. Autoimmunes are thought to be caused by that basically intestinal permeability, as are other things that could be really, really bad. So anyway, that's not a good situation. But let's talk this example through. So let's say I have a biscuit, and that biscuit has 100% of the nutrients that you need to make it through the day. And it also has 100 calories. If you're healthy, if you don't have any gut inflammation, you eat one biscuit, good to go. But again, back to our 10% argument, if you can only absorb 10%, you're going to need 10 biscuits, right? 10 biscuits to get your 100% of nutrients. It's going to cost you 1,000 calories. Wow. Well, guess what? This is where we're all at. This is where we're all at. Okay, so let's come back to this model. Again, if I was designing a human vehicle, let's say, this would be a pretty elegant way to design a human vehicle, because there's crosstalks between these systems. And the cool thing is that these systems can pick up the slack for each other if there's problems. The most extreme example of that is autism. Okay, so but let's talk through this as far as genetics. Okay, so back to this slide. So we've got our three systems. We talked them through a little bit. Let's talk this through as to genetics. So again, I like to tell this story. You and I, we decide to go on a walk. We start walking along, and as we're walking, we're chatting and talking, and all of a sudden, we walk over a lead mine. When we walk over the lead mine, when we walk over that lead mine, our bodies will sense that lead through our most sensitive organ, which is our respiratory, which has to do with COVID and a bunch of other stuff right now, doesn't it? But again, we begin to sense our environment through our respiratory. And our TRP channel will be a metal sensing channel, which will sense the lead. As soon as we sense that lead, our body will start to turn on all of these DNA repair genes, all these oxidative stress genes, and basically start trying to defend ourselves, right? But you and I don't know it. We're just walking along, chatting, talking like we are now. So as these things are turned on, though, and all this repair starts trying to happen, we're sucking resources from our normal function. We're sucking the resources that we need to metabolize triglycerides and deal with these things in our gut, right? To make our brain chemicals. Whoop, 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 sucking resources, sucking resources. We don't even know it. Hey, it's a nice day. We're just walking along, talking, chatting, blah, blah, blah. We walk off the lead mine. Again, we sense that through our respiratory. All this defensive stuff shuts down. All the cofactors go back over here, and now we can normally do our thing, right? So that's genetics. And again, how do things turn off and on? Genes. Genes turn on. When a gene turns on, a gene begins to express an enzyme. an enzyme begins to metabolize, deal with a fatty acid in a little bit different way. So you make different stuff, okay? Certain genes are a defensive gene, a DNA repair gene that turns on under these circumstances. You have, what are they, PARP genes, I think, that deal with oxidative stress. But anyway, and you know, the names are important, but all of this machinery turns on under oxidative stress. Okay, so, and inflammation. And so our problem really, the point of this is basically the point of the lead mine story is we only have problems if there's persistence, right? So if we're standing over a lead mine, now we've got all this machinery going, we're sucking all these resources, we can't make things down here, we can't metabolize things that we need to down here. So maybe we're missing endocannabinoids, maybe we're missing lower breakdowns, maybe we're missing dopamine and serotonin, maybe we can't deal with all that stuff the way we normally should. We've got all this machinery over here sucking resources. That only happens under persistence, okay? Under persistence. If we have persistence in our environment, we have oxidative stress and we have inflammation. Again, those will make changes in our gut. Our gut will begin to change. Other things will begin to turn off. Our machinery will change. And it should, because we adapt, which is really cool. So again, all we're doing is trying to deal with our environment and diet through all these machinery changes. But what we have to understand is we're not giving our body the horsepower and resources that we need to be able to fight all this. So again, if you want to learn more, there'll be a link to sign up to our Healthy platform. We have presence there. We have a whole bunch of services and more classes and all that on Healthy. But we'll go ahead and end this vlog here. Thank you guys very much. I got to shut it down, so it'll take me just a second. But enjoy doing this. And again, if you want to learn more, contact us. We'd love to hear from you. We do make products through another company called True Medics. So if you're looking for product, we have product. Anyway, see you guys.